Here we've got the integral of the inverse sine of x, and this can be rewritten as the integral of arcsin x. It doesn't really matter which way you write it, as long as you understand what it really represents. And this is actually a integration by parts problem, because this is really 1 times arcsin dx. And so what we need to do first is we'll set u equal to arcsin x, and the derivative of u is 1 over the square root of 1 minus x squared dx. And then we can set dv equal to 1, and when we integrate to find v with respect to x, 1 becomes x. And this is integration by parts, so we start by going across the top and then down over, and that gives us x arcsin x minus the integral of x over the square root of 1 minus x squared dx. And from here, we need to solve this integral, and this integral is solvable via u sub. We'll let u equal 1 minus x squared, and of course in that case du then becomes negative 2x, but we're only looking for x dx, and so to make this side x dx, we must divide by negative 2, divide by negative 2, and now we have x dx. And now we're ready to plug this all back in. So we've got x arcsin x minus the integral of 1 over the square root of u du, and this is a negative 1/2 that will kick out to the front, so this becomes a positive 1/2 in front here. And now we just need to integrate for 1 over the square root of u. And integrating for that, it's easiest to then change this integral to be u to the negative 1/2, because then that easily allows us to go ahead and add 1, and that becomes u to the 1/2. And when we do that, we have to put it over 1/2, and then we flip and we get 2 u to the 1/2. And this is now the result of our integral here. So what we have is x arcsin x plus 1/2 times 2u to the 1/2. And remember, we have to add a constant because we're dealing with an integral with no bounds. And so the next thing is to go ahead and just cancel the 2's, and then we're left with x arcsin x plus u to the 1/2 plus c. But we can't leave it in terms of both x and u. The u's must be switched back to be in terms of x. Starting from here, we did a u sub where u became 1 minus x squared. So we'll go ahead and replace u with 1 minus x squared again. And our final answer becomes x arcsin x plus the square root, to take care of this 1/2, 1 minus x squared plus c. This is the final answer for the integral of arcsin x, or sine inverse x. If you've got any questions, or if you want me to try another calculus or physics problem, let me know in the comments below. Otherwise, I hope that you found this helpful.